The question is how much work is done by the force. Well, let's find out how much work done by each one of these. So the work is going to be, let's look at the first one. The force here is 0.6. It's constant. Work is force times distance. So the work during this segment is the force, which is 0.6, and the distance traveled, which is from here to there, and that's 0.25. Then you need to add to it the work done by this force. This force is what? 0.4. And the distance traveled is 0.5 minus 0.25, which is what? It's also 0.25. And the work done by the last force, which has a value of 0.8, times the distance to go from 0.5 to 0.75, again, that's 0.25. So let's see what that number is. .45 joules. So express your answer using two significant digits. 0.45. Now the next part is how much work is done by the force if the object moves from 0.15 to 0.55. So part B is you're not going from the beginning all the way to the end. You're going to move from here, 0.15 is somewhere here, to 0.55, which is right here. Can you see for part B? 0.15 and 0.55. Well, the work here, let's look at the first one. It's going to be 0.6, but now the distance from 0.15 to 0.25 is going to be what? 0.1. The distance is only 0.1. From 1.5 to 2.5, that's 10 more, right? Add to it this work, the entire whole thing, which is 0.4 times 0.25. And the last piece is going to be what? 0.8 times the distance from here to there, which is 0.05. And that's a 0.2 joules. If they want two significant digit, 0.20. Oh. Backspace, delete, mistake, delete. Oh. Hit backspace, got out of the question completely. .20. And that's question 7.35. Let's look at 7.45. I'll use normal paper. .45. Calculate the power. Now, before I finish reading the question, we know the definition of power. Power is what? It's the work done divided by the time. And if you remember last time I derived another one, it says work is what? Work is force times distance divided by time. So if you want, you can also say the power is the force times the velocity. Let's see which one of these I'm going to use. That's the only equation I have for power. Calculate the power output of 1 gram fly. 1 gram. So the mass equals 1 gram, which is 0.001 kilogram fly. As it walks straight upward. A window pan 3 centimeters. So this fly, it's walking upward. Here's my fly, and it's walking upward. And it walked up 3 centimeters, which is 0.03 meters. Express your answer using 2 significant figures. How much work is done? Done by the fly, obviously. She's the one doing all the work to walk up, or spider, whatever the case is. Again, the one part that I forgot to mention, probably saying it moved up at constant speed. And the reason for that, because if the fly is moving upward, there's a force pushing upward on it. That's their feet pushing upward. But you also get what? The weight down, which is gravity. Mass times G. And the mass is 0.001 times 9.8. So this number is 0.0098. And the reason I kept saying constant speed, because if it's moving upward, we take the force that the fly is using minus the weight. It's equal to the mass times acceleration. If you are moving at constant speed, your acceleration is what? What is the acceleration? 0. So F minus W equals 0, which means the force equals W. Otherwise, if the fly is not moving at constant speed, we need to know what that acceleration, so we need to know how big the force is. So the force here is equal to W, which is what? 0.0098. Oh, I'm sorry, that's they're giving you the speed here. It didn't walk 3 centimeters. It walked at a speed of 3 centimeters per second. I was looking for the time. So that's the velocity. So we know what the force is. Do we know what the velocity is? 0.03 meter per second. What is the power? Force times velocity. The force is what? 0.0098. And the velocity is what? 0.03. And that's Newton meter, which is what? It is 2.94 times 10 to the negative 4. This is give us 2 significant digits. 2.9 times 10 to the negative 4 watt. Correct. I thought that was the distance. If that was the distance, then they have to tell me how long it took it to walk, because I need to know what the time is. I was about to calculate what the work done by going work is force times distance. Well, if I know what the work, then I better know what the time. That's why I went back to look at the problem. I said, oh, wait a minute. That 3 is not 3 centimeters, 3 centimeters per second. That's a speed. And the last one is 7.46. We have an ice cube is being put in a microwave oven. There's an ice cube here. You put in a microwave oven. Suppose that the oven delivers, here we go, delivers 125 watts. That watts, that tells you, is that, what is that? Is that energy or power? That's power. If it was energy, it would be in joules. To the ice cube, and that it takes what? 33,200 joules to melt it. How long does it take the ice cube to melt? How many seconds? Well, power equals work divided by time. The fact this is in joules, that's the work done. W in joules, power in watt. So 125 equals 33,200 divided by T. I don't like fractions, so I will multiply the top and the bottom by T to get rid of the T in the bottom there. $125T equals 33,200. Can we get what T is? 33,200 divided by 125, and it will take 265.6 seconds. How long does it take to melt? My numbers are 3 significant digits. So what is that, 266? And they want it in minutes, by the way. 266 divided by 60. 4.43 second. I mean minute, not second. Correct. So we'll take 4.43 minutes. They don't want it in seconds. They want it in minutes to melt that ice cube. Now just think about it. 125 watts, that microwave. Ladies, your dryer, the one you used this morning, how many watts on it? 1500 or 1250 or 1800? So these hair dryers deliver way more power than the microwave. This is 125 watts. Some of these small microwaves, they're really not that strong there.